Or can you just check your messages quickly, please?
I will. Yeah. Yeah, so the next is now, yeah. Yeah, in terms of the steps, Gerard, we can do that way. It's not a problem. It's good.
Okay, thank you. So I'd just like to swap the two sessions around. Because our guest speaker after lunch is going to do the design. So I thought I'll just go to, and let's go to the, yeah, this document that is on your, not yet on your screen. Just scrolling back up to the top. We've done the first 3 steps. Now we've looked at the costing. And I just want to go on to the design stage for now, because our guest just after lunch is going to speak on the Eskom interconnection standard. I think it'll prepare you better to ask questions of our guest speaker after lunch as well. Okay.
Yeah, Gerard, you still there?
Yes.
Sorry, just went silent.
Okay, so design, and we've actually discussed some of these aspects yesterday. In essence, you're all familiar with the standard distribution network design. You should look at all the designs of your network assets, the lines, transformers, and the associated costs that we've looked at some of them in the costing as well. So that remains part of this, especially with the example that we had just said. We've now seen from the grid impact study and the grid strengthening study that we need another transformer and 2 more sections of lines. Now, planning can do that easily. The next step is to get the network to be designed. In parallel with this, we are going to get the generator plant design. So your generator now have to design all of their plant. These 2 would happen in parallel, have few touch points, but there's very little interaction really at this point. Now, sometimes I think people get lost, and when I was much younger, I was also not sure about the difference. Now, recently, I've learned a little bit about the system engineering concept. So in essence, planning just tells you what you need to design. So from a system engineering concept, planning is the process by which you get to your design specification. And the design process is how you get to the equipment specifications. So let's first just look at the distributor network design. Now, once again, I don't have too much to say about this because everybody knows how they do their designs. Whether you do it in-house, whether you do the planning in-house, whether you do design in-house, or whether you already have consultants that does this for you. And even Eskom uses consultants for a lot of the planning and design aspects. And know in the Eastern Cape, I have, when I was still with Eskom, worked with some of these sub-consultants where they did the LV, first the planning, but also the designs and then the construction. So When you get to the network design, you probably would have the metering and everything already in a design spec. So when you do the upgrade to the 4-quadrant meter for any customer, you would already have written up what is all the auxiliary equipment that's necessary, and that would be in the spec. Who's going to do what meter are you going to install, all of that. So firstly, we say we've done the grid strengthening study, and we see that we need strengthening or upgrades. Once, and that you will do, the network planners would typically have that and do it on a similar fashion that we've just done the cost estimate letter. I know in some places the designers would already have this list of costs that they would share with the planners that can then just use that information to get to the budget quote. Also, before that budget quote is issued, I think I haven't mentioned it in the training yet, is there are several evaluation committees that would look at this. So it's like approval sections. The first one is the technical evaluation committees. So did you actually look at all the alternatives that you should have looked at? Is this a feasible option? Does it technically make sense? Then there's also a financial evaluation committee, which would look at, is this really the least cost option? If that is your policy, is this project going to be beneficial for the distributor? In other words, in the long term, is it going to make sense to do this specific project? Or are we actually just pumping in a lot of money here without any real value for this distribution network as a whole? And only then can that budget quote be issued to the customer. So even if you just go through the cost estimate and then the budget quote, or if you go straight away, you have to look at all the internal approvals before it gets issued to the customer. And then, of course, there's also always the interconnection equipment design. So, and that we will hear a little bit more about this afternoon. That's the metering, that's the protection. Physically, how does the customer or the generator connect to your network? What do you need at that point where the liability is going to change from your, as a distributor's responsibilities, down to the customer responsibilities? So the budget quote's been issued and the customer has come back and said, I accept this budget quote and we are going to proceed. In this case, in the first place, we assume that the customer doesn't opt for the self-built option. So as a distributor, you are going to design and do the construction of any of these strengthening projects yourself. So the design process then becomes to select and specify the equipment to be procured and installed. So that is, planning said it's 132 kV line. It needs to be able to carry 200 amps. And we now select, okay, planning would have selected the conductor already. Design is going to say, all right, we now need this towers, we need this isolators. There's the mechanical design, all of that, and the civil design. So we need the towers, we need the foundations, all of that, which they also mostly select from tools that's been developed over years. That's part of this select and specify the equipment to be procured and installed. Then you will assist the customer to design and install the interconnection equipment from their side, because you want this to be a smooth transition. And once the design is completed, you can start the procurement process. Now, like I said, this is a pretty standard process. The only difference is that there might be some additional equipment which you didn't require in the past. Examples could be that there would be some backfeed protection, backfeed limits that you might want to install. For the rest, the basic design would be the same. On the protection side, something that I can think of quickly is that your water reclosers. Remember the plant or the generation, no, this is the wrong picture, but the generator has 2 seconds to disconnect if there's an island connection. So if you have a recloser that is going to reclose in less than 2 seconds, that could be a problem. And I also know that Andrew will speak about this afternoon. So the bottom line is, don't stress about this too much because it's a standard process. And between planning and what we discussed this afternoon, you should be able to identify what additional equipment do you need that wasn't part of the process before. Okay, I've already said that, sorry. If we consider the self-build option, what is going to change? The customer is now going to do this whole design, procurement and construction process, which you would usually have done. At the end of it, all of these assets are handed over to the distributor's asset. Now, again, sorry about once you've selected all the equipment, once again, it's good to have the due diligence, at least meet and discuss the equipment that's been selected and make sure that all of these are correct. I think we see very regularly and we hear in the news with all the issues that, for instance, Medupi and Kusile have. It's very easy, even for somebody with a lot of experience, to miss something. And that's why it's better to have somebody outside who wasn't that involved with the project to just look at what you've done and double check that everything is correct. And especially if it is the customer for the self-built option, you have to look at his designs. Does it meet your specifications? And if it doesn't, he has to go back and improve it until you are sure that what the customer is going to build is of the same quality or better than what you would have done yourself. Okay. So the customer in this instance have to follow the distributor's processes as if he was working inside the distributor and doing this design. All the approvals, follow all the specifications, and as well as all the quality control. The last point is that the quality control, the assets, once it's constructed, and we'll get to that a little bit later again, the distributor's quality control has to sign off on the physical assets once they're installed as well. So that's part of the quality control. Any questions or comments on the distributor side? Yeah.
Jeti's got his hand up.
Okay.
Jatesh, I'm not sure how the pronunciation.
Thank you, Chair, and greeting to everyone present. Just a question from my side, maybe I misunderstood. When we say it becomes the distributor's asset, does it mean now it becomes the municipality's asset?
Yes, that's exactly what we say. So let me just pull up that other slide again. So for this example, we set the transformer, another line, and another line is going to be required. So in the traditional sense of the word, the distributor would have gone and done the design and construction for these three pieces of equipment. However, if the distributor doesn't have enough time or the resources to do this, it is also possible to do that self-build, in which case this customer is going to do the design, everything for the transformer and these two lines. Once he's done building it and the distributors signed off on the quality of the construction, it becomes the distributor's assets as if they built it in the first place. And that is also, then it also becomes part of the asset base. It can still be shared network. A line at this point in parallel with line 1. That is shared network because it also supports these other customers.
Okay, Gerard, I hope that's fine, Jitish. So it's in short, yeah, the answer is yes, but a little bit more meat. Any follow-up points?
Okay, no, that's fine. Thank you for that clarity. So even the maintenance and stuff going forward as well becomes also the municipality's responsibility. Maybe I missed that part. Sorry.
Yes, you are correct. Maintenance as well as replacement costs and repair costs becomes the responsibility of the municipality. Okay, before I elaborate on that, I see Mark also has his hand up.
Okay. Yeah, thanks. Just a general comment. Sometimes when you're talking, I think that, we've got some big experienced Munich's metros here, and we've got everything down to small Munich's. I remember once there was in one of our trainings, there was a guy from Uppington, and he did everything really. Network planning, yeah, that was him. Metering, yeah, well, that's me too. Customer service, me too. Protection, yeah, that's also me. So we've got these scenarios as well, and some of the participants will be able to relate to that sort of small municipal capacity constraint issue. And sometimes when you're talking, I think, yeah, this is manageable for most municipalities. And sometimes when you're talking, I think, wow, okay, the smaller municipalities are really going to be challenged in terms of capacity for this. And yet we know they are getting applications for these larger generators. Any comments on that? And what would you do if you were a smaller municipality and you really had a capacity constraint and you were faced with what is a fairly complex and new field, assessing and overseeing this whole larger generator application process?
Is that a general question, Mark, or specifically for me?
It's
for the
may
team?
as well be for you. What are your thoughts there off the top of your head as to what an approach could be? Because some municipalities are going to be overwhelmed, not by understanding, but by just their capacity to not be able to take this on. Just so whatever thoughts you have on that topic.
Okay, Yitesh, if you want to comment there first, you're more than welcome.
Thank you, Chair. Yeah, I think Mark brought up a very valid point because us as Amvoti municipality, we're also a very small municipality. We only have an 11 kV feed from ESCOM, 2 feeders, and then we distribute it to our town, and our residential consumer is only like 5,000, businesses like 1,000. So it is a bit overwhelming for us, and we're looking at all these big network designs and so forth. So I think he brought up a valid point. So that's why I'm also asking these kind of questions.
So Yitesh, sort of as a follow-up on Mark's question, I'll get to the other hand just now. If you have to expand your network, let's say there's a new suburb that's being developed, are you doing the planning and the design yourself, or are you outsourcing that at the moment?
We usually get consultants to do it for us. We don't have a department as such that does it for us.
Do you have a set of specification documents on how it should be done?
No, we don't. We just use a business plan. We look at a business plan from the consultant and we follow through with it. We just go over it with him and he explains it to us. So we don't have any specifications as such, but we try mostly to stick with the ESCOM specs when we're with the designs and so forth.
Yeah, that's the ESCOM docs are a very useful resource, and it's not that expensive. I think it's about 1,500 Rand a year, because they will also give you the specifications for everything, how to do the transformer, all the protection and things around that. So Mark, to get back to your question, for the smaller Munichs, actually for all Munichs, like many of the others have done, is do get access to the ESCOM docs and adapt them for yourself where you see it's necessary and it's possible. And at least at this stage, if you're already using external consultants for designs for expansion, your master planning, network development plans, it makes sense to just use the same process for these generator applications. Okay, there was another hand in between.
Ishmael.
Ishmael.
It was
Yes.
Ishmael, yes.
Hi, yes, good morning. Just in response to the question from Mark from the smaller municipalities, I agree with what you were saying, Gerard, but maybe just to add, because I think from a documentation and specification perspective, there's lots of resources available for those municipalities, the smaller municipalities, to make use of. But like I've mentioned, is this the capacity problem now, that obviously was probably a resource capacity. But I would then focus on actually the network capacity, because at the end of the day, as I've now indicated, some of them are so small, they've got 111 kV line with X amount of capacity. Therefore, there's only X amount of hosting capacity available for these generators. And once you've determined that, you basically make rules along that to say, well, you know, your smaller ones you can handle up to this point. The bigger ones you cannot handle because your capacity doesn't allow for it. And if you really want this customer to be added, they appoint the consultants to do the necessary upgrades and costing, and it becomes a self-build, for example. But that in itself becomes obviously also a decision that Munich needs to make to be able to determine do they want to go that route. So to a certain degree, it's a blessing in disguise, because at the end of the day, the capacity becomes the limitation in terms of the network availability, and that is what they would basically just need to focus on and determine where do they go with it, and how far do they want to go with it. Thanks.
Thank you, Ishmael. Yitesh.
Thank you, Chair. Just one more question from my side. Sorry for all the questions. Apologies if I didn't follow the presentation 100%. It's just a question. When we say customers who want to build and add on to our networks, do we mean like independent power producers? That's what we're referring to as customers, or if it's existing customers that we have on our grid?
Okay, that could be any of the customers. So in principle, a traditional load customer can do the same. That vehicle does exist for them to say, but I want to put up a new holiday resort in this nice small little town where you are sitting, Yitesh, and they need maybe a, a very big connection point, and because of your licensing or licensed area, they have to work through you. They can still do the self-build. They can even go to Eskom and just have the discussions as a three-way discussion to sort out those issues. That becomes a little bit more complex and time consuming, but it's possible for any customer to do the self-build option. I think I'm also looking at the comments here on the line, and I see John has made a comment. Sometimes self-build might be risky because the asset owner might refuse to inherit the network because of poor workmanship. That is something that you need to tell the customer, and why there should be at least some quality checks in before they even start the construction. Now, Josh said that the example came from, for instance, Motla Engineering. Another company that I know of is Tabile Engineering, who has got lots of experience in the first place doing these designs and managing the construction projects. And they have a lot of experience in working with Eskom. So they know what those requirements and specifications and quality expectations are. So, but they're also getting to the point where they don't have enough resources to do the work that's necessary in South Africa. But yes, you have to put it in the contract with the self-build that if the quality is not up to specification, you don't accept it. So they have to fix it until you are happy with it. And yes, I know that requires additional time, which especially the smaller municipalities might not have. But that's very important. If the workmanship and quality of the assets isn't up to spec, you cannot accept it. You're just buying yourself a lot of trouble. Does that answer your question, Yutesh?
Yes, thank you. It does. Just one last one. If this customer, for example, upgrades his lines and stuff, so we can accommodate the load that is required, maybe I'm moving to another point here. Will he also have to get other forms of embedded generation to electrify part of that line? Or will it just be solely from the municipality, his load, that we need to electrify?
Okay, in the first place, you will assume that there's no other generation, and just you have to supply that load. So if you have to go back to Eskom to increase your capacity, and that's a good example now of what we're going to get to, is you have to also engage with Eskom then to increase your capacity. So that's why especially a bigger application can be quite a big task. Remember that the embedded generators are not that reliable. You can usually not dispatch them at all. It's only in terms of the grid code that you have some control over them if they impact your network. For instance, if they have to reduce their output because they affect your network, that is what you, in terms of the grid code, you have that possibility. Maybe just quickly, and I think we have time still in this session, and I think it is important. With a 5-day training at Solar F, I think that tells of a case study in Johannesburg, where the city didn't have capacity to supply a new mall development. I think they wanted something like a 4 megawatt connection point, and it wasn't available. There was no capacity. And they had then gone and said, but they install PV on their side to assist with this load. So it is possible, but then you have to make very sure that this increase in load, as well as with the generation, that there's an agreement that if they can't supply the full load, they will shed the load themselves, because your capacity that they, in the first place, apply for, in the second place, is in the contract what they also pay for. They can't exceed that because the network cannot handle that. So Mark, does that help? I think I've tried to make the distinguish between the smaller and the larger municipalities, maybe between the number of applications that you would get. For instance, whether you would go the double quotation road, meaning first the cost estimate and then the budget quote, or if you're going to say, listen, let's just do everything at once and get a fairly accurate quote out in one step.
Yeah, I think that is helpful, Gerard. Thanks. I mean, it's still quite a challenge, I think, for a lot of municipalities, and I can see a lot of scope or need for external support when one tries to walk this path as a municipality. And hopefully we can provide some of that, but yeah, depending what happens, our support facilities might be quite stretched. But yeah, let's go forward and see how all of this pans out and see where we can help each other. Thanks.
Thank you, Mark. And I think this adds, or maybe just emphasizes the need for a lot of these documents that we've identified to the additional support documents that we want to supply as this resource pack. I just remember now there was a comment quite a bit back from France. And I think that's quite important. In this document, we've used the ESCOM terminology, for instance, the cost estimate letter and the budget quote. That is something that the developers are also familiar with. France's recommendation is to have, for instance, an application fee and then a preliminary cost estimate and a final cost estimate. And I can fully support that, especially internally. You know what kind of terminology you use when you speak to the customers, and there's no need to change that. But we've used something that ESCOM, being the biggest utility in the country, many people know the terminology, started with using those, and you are more than welcome to change it as it makes sense to you and hopefully your customers. All right. Then the next step would be on the generator planning and design side. So what is happening now?
Sorry, Kara, I just want to make sure we didn't miss any of the questions, unless it's going to be covered elsewhere. So I see here, Manalisi, is there separate cost aligned with the submission of a COC post-installation of the equipment? So that was the one question. So once the installation is done and there's work that needs to be done afterwards, I think the answer would be, it would be an all-inclusive cost. So when you give a budget quote or cost, it would include everything that needs to be done up until handover, including COCs and commissioning and fine-tuning and so on. But Gert, you could confirm that. And I think it links to Ishmael's point regarding where he said, using generic costs could cause problems. And that's why it would be better to actually use or to implement your own specific tenders to make sure that you've got your costing. And I think that's the thing, Ishmael. The costing is generic, with the idea to give an estimate of cost. Sorry about that. So ideally, you would have liked to determine your own costing, and I think this has already been done or easier to do with the larger metros, but for the smaller ones, it's quite tricky. So, but we do hear you, Ishmael. I think this is something that developers need to understand, is to say, listen, we're using these generic costs. It could be different from what we're proposing or saying. That will be determined with the final inspection or design or when we go out on tender. But just be aware the cost is indicative. It's not final. But yeah, I don't know, Ishmael, if there's something specifically you wanted to say or mention regarding that. But yeah, it is something to keep in mind. Okay, so Ishmael?
No, thanks for like you've indicated now. I just also put it in the chat to say it should then be indicated as indicative cost and not the actual cost that the customer or the applicant would be paying. Or the other way to work around it is to maybe indicate in the budget quote that that would be the cost, but after implementation there would be a reconciliation of the cost, and then whatever, because it could go the other way around as well. The customer might pay too much for what has been implemented, and then the option of reconciliation of course would also be can be considered to try and remedy that situation.
Agree. I think it should
Yes.
be, if you state it like that, you give the risk for the person paying more, but you should also be fair towards him if they pay too much. So I agree with that. Thanks. Then John mentioned something. Sometimes self-built might be risky because the asset owner might refuse to inherit the network because of poor workmanship. John, not sure if I understand that question correctly, but my understanding is that you would put out the relevant guidelines and specifications when it's a self-built project, and it's only done and accepted when everything is handed over and you have accepted that. And with that, you would have your own Q&A in place. So if it's not sorted out, you don't accept, then they don't hand over. Kara, I don't know if there's something else you wanted to mention there, or if the question is clear to you.
Yeah, I think we have discussed that one just now, that you are still responsible for that quality. And when you sign the self-built agreement, that's important that you make sure that you won't accept anything that is not of adequate standard.
So John, is that fine? Okay. Right.
Okay.
Thank you, Gerard.
All right. So then let's continue on the generator side. Now, we've split these two, step 5A and step 5B. And just let me go back to the document. So, okay, in the index, it just goes up to the second level. So step 5. There you will see step 5, design distributor network design. And if you scroll down, you will see there's step 5B, which is the generator planning and design. And very important, this includes the grid code compliance studies. So I've just added it in big bright letters there. Now, part of this design process is actually for the generator to make sure his whole network is fine. He doesn't just have to look at the small piece now. He's doing a design from scratch, from the ground up. And that is where I've also seen some interesting assumptions from people who design things. And then you have to go back and say, but you didn't think of this, or you didn't think of that. And yeah, I'll share some more just now. So the customer would, firstly, there's also, again, and he could do this in the first phase, but there's a grid impact study. So he wants to know what happens at that point of connection so that he can see if, even if you accept it based on it's a 10 megawatt PV plant, you've already looked at this and you say, okay, my voltage change is going to be, let's say 1%, and that's fine. When he's doing his design, he might see, oh, but I need an extra capacitor bank to assist with the reactive power support that's in the grid code. Now, the problem is if I switch this capacitor bank, I cause a 4% voltage change. It's then his responsibility to say, well, oops, this is actually not good. And maybe I should put in 2 capacitor banks so that's 2% for each one of them separately. So that's part of this studies at the point of connection impact, their grid impact. But for this, he doesn't need the entire network. He actually just needs to know what's happening at this point of connection. And let's show you a figure here. This would typically be the collector network. So you have some transformers down there and PV inverters connected to each of them. At that point of connection, he just needs to know what is the fault level at this in-feed point. Then he's got to do an impact assessment for his collector network and his own infrastructure. So similar to what you do on the distributor network, he now has to go and make sure in the first place that all of these lines in the collector network are not overloaded, that the voltages within this network, both on the medium voltage side as well as the low voltage side of the transformers, are within spec. We can talk about the spec just now. Then interconnection equipment design. So there's a part where the distributor designs some of the interconnection equipment as well as the generator, because they design this equipment that's going to connect together. And yeah, that's the interface. And it comes from both sides. Then very important, undertake the grid code compliance simulations, because if he's going to start building and he's not going to be compliant, it's going to cost him a lot of money to fix it at the end. These grid code compliance simulations has to be signed off by RETEC as well before they can continue with the construction in any case. Now, once again, if RETEC is going to be overwhelmed, which we suspect, I would think that, especially if it's an independent engineer that signs off and say, yes, this is all okay, that there's reasonable safety in them to continue. Then generator and related infrastructure and specify the equipment. And what are each of these equipment pieces? I've got listed here at the bottom the ESCOM standard that we will look at this afternoon. That's going to tell them at this interconnection point, how do I design that part of the network for both parties, both the distributor and the generator. So firstly, he looks at the grid impact at this point of connection. Then he's going to look at his collector network, lines not overloaded, voltages within spec. The interesting part is typically if we have a load, we would start with a higher voltage and the voltage would drop throughout this network. With a generator, you typically have an increase in voltage as you go further away from your point of connection. So they have to make very sure that they don't sit with too high voltages at the inverters. And this comes back to the interconnection equipment, the grid code compliance. The grid code requires them certain voltage ride-through requirements. So for instance, this voltage at the point of connection can go up to, for medium voltage, up to 1.0985%. And I think, I'll just double check that in the grid code again. But that there's some voltage rise in this network. And if the voltage at this point of connection is at the higher end, there's a very good chance that they're going to have high voltages in here. And their equipment are either going to fail or just trip off. Design and specify their own equipment. Right, just looking at the question here. There's a question on basically the order of these things. Is the grid code compliant simulation signed off by RETEC before the distributor grid studies or after? My interpretation is that the distributor grid impact studies would come first. For one is that you have to make sure that there's capacity on the network or that the capacity can be created before they go to the steps of actually doing the grid code compliance and their own design or the full design. Sorry. And the next is that when you do the evaluation, you know what their plant, how their plant should respond, because that's also contained in the grid code. So you do your studies or have the consultant do the grid impact studies for the distributor network, taking into account that you have a grid code compliant generator. And then they just have to prove that to RETEC. Okay, now, what is your responsibility when it comes to the generator network design? The interconnection equipment, that's important that you speak to each other and make sure that you've got that correct. The power quality, they don't need to simulate that anymore. Originally, there was a request that they simulate this. The only thing that needs to be checked is resonance screening. And that's typically due to all the cable capacitance. And even if they add capacitors, you don't want a resonance condition on your network. Now, this is something that I think is a little bit of a concern, because I know Eskom has got reasonable network models with which one can do this. Some of the municipalities have got their networks up to medium voltage. Resonances are typically less of a concern there or easier to determine because it's short lines in the medium voltage network. But that is something that remains the responsibility of the distributor. And then, of course, the protection coordination. Follow-up question. Does RETEC issue formal approval to the generator or distributor with respect to grid compliance? I'm not sure. I think it's the generator's responsibility to apply to RETEC directly, and they will receive the approval if it's done. It doesn't have to go through the distributor. But I do think as a distributor, you should request that approval from the customer or the generator.
Sorry, Gerard, do we have anyone in the audience that has that experience in terms of the involvement from RETEC? Would be interesting to hear or confirm. I think you're right, Gerard, but would be good to hear the reality or confirm the reality.
Okay, we can look at the checklist as well just now. Okay, my experience is basically with IPPs that connect to Eskom. And Eskom or Retech comprises a lot of Eskom people. So the communication is between Eskom and the customer, and very often directly to the consultant where I fit in. So yes, that's, I'm not sure. I don't think it will necessarily, some of it will go through the distributor, like I know the power quality aspects do, because Retech just said they have no idea what needs to happen with power quality, and they just moved it all down to the utilities. Okay, so let's look at the checklist quickly. So for that, I'm just going to scroll back up to the top. And then the checklist, Appendix C. Now we've done steps 1, there's 2 and 3, 4, and then that's still part of 4, there's step 5, design. So in the first place, on the distributor network side, basically, have you compiled the technical specifications and approval? And that is through your technical evaluation committees. If you are using external consultants, I would recommend that you just ask them to give you some sort of assurance. And that could be a letter to say that, yes, we meet all the relevant specifications and have done the internal quality checks. And then you can tick this off. The capital approval, that would also go through some other committee, and your budget and finance departments, whether you have it. Obviously for self-build, this is easier. Then as the procurement started, that can obviously only happen once everything is in place. Have you given the guidance to the customer so that the interconnection equipment can be designed? And I do think in this place you will have to have meetings with the customer to make sure that that collaboration takes place. Then on the distributor network, have you done the metering equipment? Has that been designed? Oh, sorry, that's construction. No, okay, so that's just the design here. So there are no checks here for the customer's equipment or the generator's equipment. It is just for the distribution network and ultimately the interconnection equipment that's got a separate tick box. Okay, so let's just quickly look at the responsibilities. So I've now, that's just to get you guys all thinking, and I know with 100 odd people, it's difficult to all participate, but we've got the two parties here, the distributor and the customer. And I've made a list of some of these parts that's being designed. And let's see, what do you think? The first one, the collector network. Who's going to be responsible here? Would it be the distributor or the customer? So let's say, who says it's the distributor? You can raise your hands. Okay, people are typing. I've got one that says customer and one that says distributor. Two more customers. Okay, maybe just to emphasize again, the collector network is this part of the network. It collects the energy from the individual generating units. And that's because PV and wind generation typically is over a wide area, all that energy to one central point, which is different from a typical coal power station where everything actually gets generated in a small space. Okay, so I see I get a lot more people saying customer. So yes, that is the customer's responsibility. Now, I would, if you've got people with experience, yes, you can speak to the customer about this and tell them what your experience is. But this is very important, never to take any responsibility for the customer's collector network. Up to that point of connection, up to the interconnection equipment, is totally their responsibility. Because whoever said yesterday, they know consultants now. They are going to come back and tell you it was your fault. So as a distributor, you do not say anything about their network. It's their responsibility. Okay, then the distribution network. Who's responsible for that during the design phase? There's 1D, distributor. Okay, cool. So yes, it's the distributor. Now, what about self-build? It still remains the distributor's responsibility for the distribution part of the network. So even if the customer is going to do the designs and the construction under a self-build agreement, it is still the distributor's responsibility to make sure that all the necessary checks are in place. Okay. Oops, I've given away the answer there. Metering, responsible there. See, people are still awake, and that's an easy one. The metering equipment in any case remains or is always the distributor's equipment or their property. Next up, grid code compliance. Who's responsible during the design phase? I see a C and then I see both. Few C's. Distributor. Okay. During the design phase, grid code compliance is the customer's responsibility. The distributor can look at it and they can also have discussions, but it's the customer is always responsible for the grid code compliance. And then interconnection equipment. Customer. Got a few customers. Well, I would say there's a responsibility for both during this stage, because you want to make sure that you have that interconnection. Then protection. Shiraz says the distributor specifies it. That's in the interconnection standard, yes. Okay, there's a lot of people that say both now. Once again, protection needs to be properly integrated between the two parties. And lastly, the power quality. During the design phase, who's responsible? I've got a both, I've got a customer. Okay, in this case, I would just say it is the customer. During the application and the evaluation phase, the distributor has a responsibility and a big role to play. And it's during this phase that the distributor would say, these are your emission limits, or reference the appropriate standards. When it comes to design, it's the customer's responsibility to make sure that he's going to meet those limits. Once again, you can have a discussion with them and say, well, it looks reasonable, but do not take any responsibility for it. The only thing that would be the distributor's responsibility is resonance screening, and that's done with can be done with a lump model from the customer. Okay. So just to summarize, you've got network design and generator design, upgrades, protection and metering. The generator has quite a bit more work on a design because he has to design his entire network as well as look at the network impact and the grid code compliance. And in terms of the responsibilities, there are some parts that is either one of the two parties' responsibility. Some of them could be both. But it's very important as a distributor, never take responsibility for anything on the customer's side. Don't approve it because it's going to come back. Okay. We might have a minute or two before we go to the quiz for a few questions.
Yeah, are there any other questions? The quiz specifically is only for, you're talking about the quiz or the checklist? Because the quiz is for the end of the day.
Yeah, the checklist, yes.
Okay. Yeah, are there any questions from the audience? Any other questions or comments? I was actually thinking, Gerard, if we could, the activity you had just now, maybe just do it in another format so that we can just embed the understanding of responsibilities, because it is a crucial one. And I saw from the responses, some of the topics, it was not clear if it's the one or the other or both even. So it would be good if we could maybe do another round just to embed who is responsible for what. But yeah, are there any other questions? Gerard, could you just quickly double check if that checklist is suffice, what I've sent to you?
Yeah, I think that is. And we can just think of the example that we've used earlier, where we said we've got this network and we're going to add a transformer and two sections of lines. And just think in terms of what you would do, whether you would tick this off and think for yourself, what would you, what are the processes? And then ask the questions and highlight where you guys still need guidance on how to get to that point. Okay, so I'll stop sharing and hand over to you for. Did you want me to go through that slide again that we just had discussed, or?
Sorry, Gerard, which slide is that?
The one where we did the responsibilities.
Yeah, no, it's fine. You can maybe just send me that list or just a screenshot, but I can just compile it in a different format. But in the meantime, I just want to make sure we're going to do step 5 now, right? Step 5's checklist.
Yes, that's correct.
Okay, so I'll send the link on MS Teams and on WhatsApp. And then you can go through it. Okay, so Gerard, if you maybe just want to quickly just recap, what is it that they need to do for the Google form, and then once we've got the responses, we can quickly look at who's saying what.
Now let me just share this and just to make it clear what we think. Sorry, my computer is not playing along. So basically what I'm saying is that think about this in terms of adding another 2 lines and the transformer. Let me share the checklist here. So in terms of your processes, are you going to how you think about how you're going to do the technical specification and approval? Because that has to be done. Then the capital approval, procurement starts before you can obviously do the construction. And then would you speak to the customer? And how would you go about this? So that would be in that checklist. We've also added a not sure column this time. So if there's anything that you're not sure, then just add in the comments where you think there are still gaps for your understanding.
Thank you, Gerard. Okay, so let's give it a go. We'll obviously go together as a group through the checklist. But please, I really would like to encourage everyone to participate so that we can keep record of who is participating in this training. Gerard, would you just quickly send me a screenshot of that distributor versus customer presentation, just on WhatsApp, please?
Right.
Okay, responses are coming in. Already sitting with 11 responses. I might share to see if we've received your response. So there you can, if you can see your name, we've got it. Google tends to jump around. Okay, sitting at 43 responses. Like I said, if you can see your name, 45. Sorry, if there's a response coming through, then it jumps. Okay, so I think the gist of it is there. Let's just look at the feedback. Okay. So if we look at the technical specification and approval, distributed assets and integration assets, bulk of the people said it's yes. 2 said it's not applicable. Gerard, sorry, are you online?
Yes, I am.
Okay. Would you mind maybe just clarifying, because I see there are 2 that said, you know, it's not applicable, why it would not be applicable, or why you would want to say you tick it off for someone applying for it. That's not for the first step. For first step of step 5.
Sorry, I was muted still.
Okay.
I think it's important to remember that there is always metering and protection impacts. Well, the protection might not have an impact, but there's always the meter exchange. And that, at the very least, needs to be done. That would go, yes, there's a standard. So you, in that case, you won't have to take it through all the specific approval processes. But if there's any network upgrades, you definitely have to take it through appropriate processes. Now, coming back to Mark's comment, if it's a very small municipality, like a one-man band, where you outsource this, you will need them to provide some form of assurance that this has been through a rigorous process before you can tick this off.
Okay, so that's on that first one. Second one is capital approval. Again, my box said yes, and then there's a few that says not applicable, and you can see there's quite uncertainty regarding the capital approval. So maybe just explain. Yeah.
Yeah. So on the capital approval, that would again be your own process that you need to do. As part of your license conditions, you need to be an efficient utility. So you can't just spend money without it being also approved in line with the budgets, and not excessive spending. That's the MFMA, all of those things. I think the not applicable might once again be for smaller generators where there isn't actually any additional work that needs to be done. If you've got the standard process or policy, for instance, for just a meter exchange, of course, that's already gone through approval processes to have that specification, and then you can continue with that. Not sure. Yeah, maybe somebody would like to say what.
We can quickly check in the comments. Obviously, that is now for everything above. Application must include all information. For any changes on the network infrastructure, capital approval is required. Okay, depending on the internal resources of the distributor, the design work and specifications might be outsourced to a consultant or generator. So then again, it's not applicable to them. Capital approval plus a procurement will be given to the customer to complete for distribution to approve. Distributor to have technical specifications available for lines, transformers, peripheral equipment at substation. Distributor have a standard available for self-build option. This will fast-track procurement from the customer end. These standards will also determine the capital approval, who would be responsible to bring about what equipment and infrastructure. And then smaller Munics will outsource to obtain the technical specs. The process requires capital approval and procurement. Distributor provides the specs, but design is the customer's job. Design, integration, quality supply, protection factors critical to amend accordingly as specified. And then funds not reflecting. Okay, so those are the feedback. So I don't know if that given some indication of why it's not sure.
Maybe a comment there, because I was sort of surprised when I heard this. When customers opt for self-build with Eskom, there are all the technical evaluations and then also the capital approval. They have to go to the Eskom capital approval committees before they can proceed. On the one hand, my feeling is, okay, usually the customers can do it cheaper than Eskom can do. So why does it have to go through that process? On the other hand, they might be, it assists with checks and balances. If that price suddenly is too much lower, it would raise a red flag. They've said they meet this quality requirement, but where in China did they go and source this specific transformer now that suddenly is so much cheaper than the norm? That is said tongue in cheek, please don't take it too seriously, but that's just to help ensuring the final quality of the product. Okay.
Good. And on procurement, we saw also the bulk of it says yes, some says no, we're not going to procure it, we might want to outsource there. There was also a little bit of uncertainty, but I think you've addressed that with your comments. And then in terms of the guide specifications provided to customer regarding interconnection equipment, bulk said yes, we will have a guide or specification, and some of the notes also alluded to that they still need to, they don't have something yet, but they will try to obtain some of it so that they can provide it. So I think that's good. So anyway, okay, so great. Thank you for the participation and feedback. I still see not everybody has responded, so I hope that you know that these 40 odd guys are actually here, not just the online presence. Okay, any questions or comments on this? Again, the idea of this exercise is just to expose you to the checklist and to apply your mind, because it's easy to say, okay, I've got a checklist, I know what to do. But as soon as you're in the field and you start applying it, then you realize, what does this step actually entail? And is it really applicable to me? Or how would I apply it in the context of self-build versus, you know, doing it internally? So I think it's a good to get that exposure. And obviously, ask the questions now if you are not sure. So any questions? Thank you, Franz, for that one-man band. Loving it. Okay, any other questions or comments? Gerard, after the break, what's up? Will that be the guest speaker, or will we continue with your presentations?
As far as I know, the guest speaker would be here at 2 o'clock. I'll just see if I can get all of him now during the lunch break to confirm.
Good. Okay. So just from our side, we have a poll that we would like to. We don't have time for it now, but we do have some polls which we're going to issue on MS Teams. At least one, possibly 3 of them. So my request would be, or our request would be, is that during the lunch break, when you have time or when you're back a bit earlier, just respond on those polls. We just want to have a feeling of what do you plan as a municipality when it comes to the different cost letters, and what do you guys plan in terms of charging a fee for those different cost letters. So you guys are welcome to respond on those polls, and then we'll look at that at 2 o'clock when we get back shortly just before our presenter. Okay, so if we quickly recap, we're done now with up to process number, we skipped, which was now. We did step number 5, so 3 and 4 we still need to do. There's the poll. Thank you, Sanawu. So this we will then continue with this afternoon, but we will first have the guest speaker talking about the standards for interconnection. C team, is there anything else before we let them go for lunch?
I'm good, thanks for
Great, thank you. Okay, right. Thank you, Tsepo. I'll add you on WhatsApp. Okay, ladies and gentlemen, let's have some lunch. We return at 2 o'clock. If you have time, respond on the poll in the meantime, and then we will look at it when we're back. And if there's any people that needs to be added on WhatsApp, please let us know. Send us the message and we'll add you. Great. Okay, enjoy lunch, everyone. We'll still be here for a while. Alan, just provide your cell phone number, then we can add you on WhatsApp. Thank you, Alan. We'll add you soon.